All right, welcome back to lesson 3 of Math 3 Term 3. Today we're going to talk about realistic domains and ranges based on models. So in order to get started with this lesson, I wanted to show you an example. Say you are standing here and you have a ball in your hand and you throw that ball up and then eventually it comes back down. Okay, so this is the ground that you're standing on, right about there. And this is where the ball starts. So the ball's starting right here being thrown. So that would be considered like your y-axis. So let's call that y and let's call that x. Okay, so the ball starts here. Notice the ball isn't at 0 when it starts. It goes up, it hits a maximum, and then it comes back down, and then it hits the ground. So my first question for you guys is, does the ball go through the ground? When you throw a ball, does it go through the ground? I mean, if it's a ginormous ball, it might dent the ground, but the ball does not go through the ground. Does not go through the ground. Does not go through the ground, okay? So that's my first note that I want to tell you guys about. The second note is, does the ball ever have negative x value, right? So we know that this is a parabola, a quadratic or a parabola. Okay, and so this technically is going to go on forever and ever, and this is going to go on forever and ever. But that's in the math world. We're dealing with a realistic situation here. So in a realistic situation, this 0 value is going to be the lowest x value that it'll ever be. It'll never be negative because my x value represents time. So because the x value represents time, there's no such thing as negative time. So the smallest the x value can be is 0. Same thing with the y value. The smallest the y value can be, bottom and top, is 0 because the ball does not go through the ground. So here I'm going to also put can't have negative time, which is our x value. So when we're dealing with realistic domains and ranges, no matter what the equation is, when I look at my realistic domain, first I have to remember what domain is. Domain, that's our x value. So the realistic domain is going to be the stretch of the x values that this ball is going to travel. So this is my realistic domain. So as we see, my realistic domain can never have a negative. It can never have negative time. So my realistic domain is always going to start at 0, no matter what. And it's going to be a closed bracket because it does indeed exist at 0. It just can't be negative. Okay, so my realistic domain is going to start at 0, and then it goes, the ball is taking its flight, and then it comes back down and it hits the ground. So we know how to find this point here. This is called an x-intercept. We've done this a million times, right? So it's going to go from 0 to this x-intercept, and I'm going to call it the positive x-intercept. And the reason I'm going to say that is because there's two x-intercepts. There's one here and there's one here. But we know that's a negative value and you can't have negative time. So our realistic domain is always going to be from 0 to the positive x-intercept. How do we find the positive x-intercept? Well, there are a few ways. We can graph it. We can factor it if it's factorable. We can use the quadratic formula, or we can use completing the square. Now, in this lesson, I'm going to show you graphing and quadratic formula because those are the two that we'll most likely be able to use. Okay, so that's finding the realistic domain. Notice that's a closed bracket on the positive x-intercept because the ball does exist there on the ground. It's just not going through the ground. Okay, so that's my realistic domain. Now I want to know my realistic range. Now range, realistic range. Range is going to be from the bottom to the top. So my range is going to be this distance here from the bottom to the top. So the lowest that the ball will go to the highest that the ball will go. And we know the lowest has to be 0 because it does not go through the ground. Now I know it doesn't start at 0 here, but it ends at 0 here. So this one goes lower. So if you go like this, you want to make sure you're keeping in mind for the realistic range every single y value that's possible. We know the lowest is 0. Once again, closed bracket because it does exist at 0. And then it's going to go all the way up to the highest point. Remember, this is your vertex. Okay, your vertex, I also call it the nipple. Okay, the vertex. And range, these are your y values. Y stretch, y values. So it's going to be from 0 to the y value of the vertex. And that's going to be your realistic range. Now, how do you find the y value of the vertex? Great news. We've done a ton of this before. So we are going to step 1, find x value of vertex by using negative b over 2a. Step 2, plug x value into equation and solve. Okay, that's one way that you can do it. Okay, so find the x value of the vertex by using x equals negative b over 2a. And then once you find that, you're going to plug it into the equation and solve. The other way that you can do it is by graphing. And I'm going to show you both of these versions. All right, so for this lesson, hopefully you have these notes. If you don't, press pause. Make sure you get all these into your notes because these are going to be important notes for you to have. This is basically your cheat sheet on how to do all of these problems. Make sure you have your calculator with you. In this lesson, I'm going to be using the TI-84, but you can also use the TI-Nspire. It's quite easy to use that one as well. And we're going to have our lesson with us, okay? So actually, not the lesson. I'm probably going to be using just example problems from the lesson. So let's go ahead and move on to some example problems from the lesson, and I'm going to keep my cheat sheet right here. So I'm going to go to my lesson, and here's number 1. Now, number 1, you can do it faster than you think. And the funniest part about this is you don't even have to read the question. What is the realistic domain? Look at all those minimum values. Negative infinity, negative 0.11, 0, negative 0.11, negative infinity. Well, the question's asking for the realistic domain, and I'm throwing a baseball up, and then it comes back down. I don't even need to read this to know that the answer has to be this one. Why is it this one? Well, it has to be that one because in the realistic domain, the minimum value is always 0. And that's the only one that has a 0 as the minimum value. Okay, so if that weren't the case, if we didn't know that 0 was the minimum value, or say for example there were a few of them with 0 as the minimum value, then let's solve it out. Okay, so I have my quadratic p of t equals negative 16 t squared plus 51t plus 6. The question is asking for the realistic domain. Find realistic domain. Now, I know already that it's going to be 0 to something because we talked about this before. Realistic domains and realistic ranges are always going to have a minimum value of 0. Okay? So for the realistic domain, it's 0 to the positive x-intercept. So I have to find that positive x-intercept. which I can do by graphing or the quadratic formula. I'm going to show you the quadratic formula first, then I'm going to show you how to do it graphing wise. So quadratic formula. If you can recall, the quadratic formula is x equals negative b plus or minus square root of b squared minus 4ac all over 2a. All right, how do you find your a, b's, and c's? A is always in front of the squared variable, so negative 16. B is always in front of the variable by itself, and C is always the one out chilling by itself. Anytime you plug anything in, you're gonna use parentheses, so make sure you put parentheses in when you plug all this crap in. So I have, let's just do it right here, x equals negative parentheses plus or minus the square root of parentheses squared minus 4 parentheses parentheses all over 2 parentheses. So I know this is going to be a b value, which is 51 plus or minus square root of b, 51 squared minus 4a, negative 16 times c, which is 6, all over 2a, which is negative 16. So I plugged in all my variables with those parentheses so I don't screw up. Now you can do this whole thing on your calculator if you plug it in correctly. The reason there's a plus or minus is because there's going to be 2 options. Do the formula once with the plus sign, then do the formula again with the minus sign. Then there are going to be 2 options. Because like we saw here, there's an x-intercept here and an x-intercept there. So we're gonna have 2 x-intercepts, but we want the positive one, okay? So I just naturally always do the plus 1 first. So I'm gonna put parentheses, negative 51 plus, and then I have a square root, 51 squared minus 4, and then I just do parentheses like it is in the equation, negative 16, parentheses 6, and then arrow out, and then I put a big parenthesis on the outside. The reason I do that is because I've now put the entire numerator, the entire top part, in parentheses. So I just plug all that in, divided by parentheses, 2 parentheses, negative 16, parentheses, parentheses. So hopefully that made sense. This is how you can plug it all in at the same time into the calculator. Now it's beneficial to know how to do that because the biggest issue that people have with this is order of operations, and they also mess up their signs here. So negative, negative, positive, you know, negative times a negative is a positive times a positive. So some people mess up their signs there, and then some people mess up order of operations. So it's good to know how to plug all this crap into the calculator. If you do it all at once, make sure the numerator has parentheses around it, the top part, and the denominator has parentheses around it, so your calculator doesn't calculate incorrectly. Then I press enter. Notice I get x equals negative 0.11. So can that be my answer? No, that cannot be, because I want the positive x-intercept. So what this found is this x-intercept right here. So that means I just have to do the same exact thing, but now with the negative. So I'm literally just gonna go up to it, highlight it, press enter, and then now it has it all over again, but I can edit it. So I'm gonna go back and turn that plus into a minus. And then I get x equals 3.3. That can't be the answer. That has to be the part of my domain. So that tells me my domain is going to be 0 to 3.3. So that is my realistic domain. And I'm going to put a D for domain. That's my realistic domain for this problem. All right, so I know I went kind of fast there. That's the way to use the quadratic formula. Now let me show you how you can do the same exact question, find that same exact 3.3 value by using graphing. So first I'm gonna make sure everything in my calculator is cleared. Okay, so I went to my graph, which is y equals, and now I'm literally gonna just plug in this equation right here, this negative 16t squared plus 51t plus 6. And instead of t, I'm just gonna use x. So I have negative 16 x squared plus 51x plus 6. And then the graph button is right here. I'm going to press graph. Now the graph doesn't always show up the way you want it to show up, but sometimes it does and sometimes it doesn't. I'm lucky I can kind of see it right there, but I'm going to go to zoom, and I'm going to zoom in actually. I think that would be the easiest. But basically you want to play with your zoom and your window until you can see it pretty clearly. So notice with the zoom, I just move the cursor around and I press enter, and that's going to zoom in hopefully around it. So now I can kind of see, let me just do this, zoom box, because then I can just really focus in on the part of the parabola that I want. So I press enter and I literally create the box that I wanted to zoom in around. Now I know I'm looking for an intercept, which means I need to make sure that my x value or my x-axis is actually there. So zoom box, let's see if it does it for me. Okay, so I'm gonna go to my window. Like I said, you're just messing around with it until you get what you want. And I'm gonna change my y minimum to -1, and I'm gonna graph it again. If you're graphing on the TI Nspire, it usually creates the window for you, so it's a lot easier than the TI 84, just to let you know. All right, so now I can actually see that x-intercept there. So now I go to calculate. Notice that calculate is in blue. So I go second calc, and I want to find a 0. So remember, a 0 is another name for an x-intercept, and it says left bound. That means you want the flashing light, see the flashing thing, to be on the left of that x-intercept. So I'm gonna press enter. Then it says right bound. Now you want to move the flashing thing so that you're on the right of the x-intercept. Well, I can't see it, but I know that if I'm on the right of the x-intercept, I must be below. If I'm on the right of the x-intercept, I must be below the x-axis. So I must be with negative y values. So once I see negative y values there, I know I'm to the right of it, and I can press enter. Then it says, do you want me to guess? So it's saying guess the 0, press enter. There we go, the x value is 3.3. All right, so then I know my domain is 0 to 3.3. With the TI-84s, I do think that process, if you don't know how to do it quickly, is kind of a little bit more complicated. So if you remember the quadratic formula and you remember how to plug it into the calculator, that actually might be kind of faster, but that's up to you. All right, so now let's move on to the next question in the quiz. I'm gonna do an example of finding the realistic range. Don't forget in these types of questions where it says type the domain, be sure to use proper interval notation. You wanna type it in like that with the bracket, 0, comma, the number, bracket, and it says rounded 2 decimal places. So if I were to type this one in, I would have wanted 2 numbers after the decimal. So just be careful when you're doing those, okay? All right, so here's one, find the realistic range. Now in this question, once again, we don't even have to read the question because look, this is the only option with a 0 as the minimum value. So we know that has to be the answer, but not all of them are like that. We just got lucky with 2 of them like that in this particular quiz. So let's pretend that that's not there. Okay, you're 6 feet tall, you throw a baseball up with an initial velocity of 51 feet per second, creating the equation P of t equals -16t squared plus 51t plus 6, where P of t represents the position of the ball based on time and t represents time. What is the realistic range for the problem? So that's a lot of words and a lot of crap. The only thing you actually need is this equation. A lot of the explanation around it is just explaining why those particular numbers are there. You're 6 feet tall, so your C value is 6. The velocity is 51 feet per second. That's why your B value is 51. You don't even need to know that crap. You just need to know this equation and know what the question's asking for. Realistic range. Okay? So we know our realistic range is going to be, realistic range is going to start with a 0. We know that. because that's how realistic domains and ranges work. It's going to start with 0. Now, how do I find the realistic range? I'm going to get the y value of the vertex. So I find the y value by using the x value of the vertex, which is negative b over 2a. Then I plug that into the equation and solve. So I have p of t equals negative 16t squared plus 51t plus 6. So it's the exact same equation that we used before, which is kind of lucky. Okay, so I know my a value is the number in front of the t squared. My b value is the number in front of the t. And my c value is the number chilling by itself. In order to find the x value of the vertex, I have x equals negative b over 2a. So once again, whenever I plug anything in, what do I put around them? Parentheses. So I have negative parentheses over 2 times parentheses. This on top, negative b, so I'm going to use my b value, which is 51, and then 2 times a, which is negative 16. So that's negative 51 over negative 32. Well, what's a negative times a negative? Positive. What's a negative divided by a negative? Positive. So that's going to end up being positive no matter what. And then I have 51 divided by 32, and it's 1.59375. Let's see if it's a prettier fraction. Nope. And I'm just going to leave it, 1.59375. So that's the x value of the vertex, but the realistic range doesn't want the x value, it wants the y value. So in order to find the y value, you plug the x value into the equation and solve. So I'm going to take this equation and I'm going to plug this in for the x value. So I have negative 16 parentheses squared plus 51 parentheses, I should have made my parentheses bigger, plus 6. So this is 1.59375. Sorry, it's so small. 1.59375. Get my handy dandy calculator. And then I literally just plug this crap in. So I have negative 16 parentheses, 1.59375 parentheses. And then squared, plus 51 parentheses, 1.59375 parentheses, plus 6, and enter. So that is going to give me a y value of 46.6. And because it's multiple choice, we don't have to round to a certain place. So I just say 46.6. So my realistic range is the interval bracket 0, comma 46.6 bracket. That's my realistic range. And I look at the answer that I had originally selected, and there it is. Okay. There's also a way we can do this on the calculator. So I'm going to graph it. I have it in the y equals, press y equals, type it in, and press graph. Notice I can see that tip there, that's my vertex, and that's what I want to find. I want to find the y value of that highest point. So once again, I'm going to use calculate, so where I press blue to make the blue thing happen. And look, I want to find the maximum, because the maximum point is that vertex. So I went down to maximum, press enter. Now it says left bound. I want to make sure the flashing thing, so I see my flashing thing, I'm going to move it until it's to the left of where I think the highest point probably is. Press enter, then I'm going to move it to the right of where I think the highest thing is, and then I press enter, and it says guess. Why, yes, I would love for you to guess, so I press enter. There's my x value of the vertex. Isn't that what I got here? And there's my y value of the vertex, and that's what I got here. So that's the way you can do it on the calculator. I hope this helps with your quiz for finding realistic domains and ranges. If you guys have any questions, just reach out to me. You guys are doing great. Keep it up. Wonderful job.